All right. So today we are going to study about Viterbi algorithm. Let me share my screen. Okay. So just a quick recap of what we have done in the last class. So that was, first of all, we have a sentence and we generate Pierce tags related to each and every word. We assign tags like it's a noun, it's a verb, or any other part of speech. Then we calculate transition matrix. So transition matrix is basically gives us the probability of moving from one part of speech tag to another part of speech tag So this gives me probability of moving from one state to another, basically between states in a transition graph. Then we have emission matrix, which gives us the probability that a word occurs in a part of speech tag. For example, few words occur in two or more part of speech tags. So we have to decide which one is having higher probability. We select that one. If I am at a part of speech, for example, I had given example of back or maybe bank. So bank, it can be noun or it can be used as some verb or something. Okay. So if I'm on a verb state, I need to calculate what are the chances of appearing of bank in that uh, verb state, and if I'm at a noun state, what are the chances of appearance of that word in a noun state. Okay, so emission matrix gives us the probability of occurrence of a word in a vocab given a POS tag. Okay, so this is what we have studied in the last class. Now let's see. There's one more thing. So first of all, we have to follow a few steps. Like first of all, we have a data set. We pre-process it. Pre-processing means we need to remove stop words, we need to do stemming and all, and we need to generate vocabulary out of it. Okay, so we do pre-processing, and then we add starting and ending tags in between around each and every sentence, right? After that, what happens is we assign Pierce tags. After assigning Pierce tags, there are some words. Suppose in training, I had 1,000 words, and while I was testing the model, at that time some new words arrived which were not there in the model previously. So such words are called new words, or you can say uh, which were not already existing words. So what in that case, what do we do? These are called out of vocabulary words. So what do we do in that case is we add one tag called special tag called unknown for new words on which our model has not already been trained. Okay, so we assign this unknown tag to those words, and then we proceed exactly same way like we generate probabilities and so on for this unknown tag as well. Okay, so chances of basically we assume like chances of appearance of some new word in the testing data is very less. So that is why we say all the very low frequency word in our corpus, we can also assign unknown tag to those words. Okay. Now after this whole pre-processing is done, we'll move on to Viterbi algorithm. Now what does it do? So after these steps are followed: data, pre-processing, starting and ending tags, POS tags, and processing maybe out of vocabulary words. After that, what do we do is we generate this transition matrix and we generate emission matrix. So transition matrix we have discussed, like probability of moving from one POS tag to another, chances of appearance of second POS tag given first POS tag. And similarly, we have emission metrics, chances of appearance of a word in a particular POS tag. So these two metrics will generate We have discussed the formulas for that, probability formulas for that in the last class. Okay, we'll start from here itself. Now, after generating these two metrics, what we'll do? So we'll apply this Viterbi algorithm. Let's see how this works. So basically, what we want to exactly do is uh, so we want to basically generate the most likely sequence of POS tags. We want to generate like after we want to calculate these POS tags and what are the chances that this sequence will appear in the sentence. This sequence of POS tags will appear. Okay, so we want to calculate that basically probability of the whole sequence of POS tags, right? We want to know like which this is noun or not, this is next would be noun or verb or not. So this is what we want to calculate. Now let's see example. So example sentence is I love to learn. Okay, so I have only first the start word, which is starting symbol, and I want to know what is my first word. Whether it's a noun, it's a verb, or any other thing. Noun is first state, verb is second state, and any other thing. This is the third state. So, what are the chances that my first word in the sentence is either verb, other, or noun? Okay, so the sentence was I love to learn. So I have to check I is appearing in which out of all these words where I is appearing. So I is appearing over here. So first of all, so probability of occurrence of this word I is I was on the initial state pi. This was my initial state. And what are the chances that I transit from this pi to other, and plus what are the chances in other that I is appearing. Okay. So this is calculated from transition matrix, which will give me the probability of moving from one state to another, multiplied by the matrix, which is emission matrix, which gives me the probability of chances of occurrence of I given a particular state. Okay, so for that over here, so this was point 0.3. Let's say just for example, so this I will calculate from the transition matrix, and this value I'll calculate from the emission matrix. So multiplying these two will get 0.3 by 0.5, so 0.15. So chances of appearance of I as a first word in my sentence, that is moving from initial state to my first word, is 0.15. Clear? This is how थोड़ा थोड़ा यस एक बार फिर से क्विकली देखते हैं कि क्या कर रहे हैं हम इसमें. हमारे पास एक सेंटेंस है आई लव टू लर्न, and I want to know what are the chances of occurrence of that sentence in the corpus. Okay, so what are the probability of occurrence of that sentence? So for that sentence I have created POS tags, and I have created transition matrix and emission matrix using the probabilities. uh, After that, what I want to know is what are the chances of occurrence of this I as a first word. What are the chances of occurrence of this I as my first word? So for that, because I have added this start and ending symbol, and from start, this is initial state, I was having initial state. So what are the chances of appearing this I as my first word? Because I was appearing over here, so I will see first, I will check the transition to that state. If I was appearing over here, so I will check the transition of from pi to that state, and then I would check the emission value in the emission matrix given that word is appearing in a particular state. Okay, so this way we have calculated. Now we have multiplied this emission probability and transition probability and emission probability, 0.3 into 0.5. So this is 0.15. Similarly, we'll move on to next word. Now this, you can see this word love is can be used as a verb. and can be used as a noun. So love is over here and over here. So it is present in two places. Now I have to select which one is higher probability, right? So I'll calculate these two and I will select which one is higher. Okay, now I was on O. I was on this O state, which was my POS tag. So from O, I can either go to this path or I can either go to this path. So I have two paths to traverse. Now I will calculate the probability of both of these and I will select the one which is having maximum probability. So this one was having maximum probability zero point 0.5 and into zero point 0.5, and this one zero point 0.5 into zero point 0.1. So I will select this one, this path over here. Okay, so transition probability multiplied by emission probability. Similarly, after I have reached to this state, now I am at the verb state. What are the chances that 2 will appear if I am on a verb state? So 2 will appear over here. So I will come back over here and this is transition and emission. So zero point 0.2 into zero point 0.4. So that is 0.08. Similarly, I will find the probability of learn. So the probability that next word is appearing given my previous word depends upon what POS tag it was in plus what word it is wanting. Two things. Okay, so it is quite clear, like if I want a verb in the next place, so I need to know what was my previous tag and which word I want to predict. Basically probability I want to calculate for which word. Okay, two things are required basically. So this is what this whole scenario is depicting. Now, final probability is the multiplication of chances of this, appearance of this, into chances of appearing of this, into chances of appearing of this, into chances of appearing of last word. So final probability for the sequence is multiplication of all of these, 0.15 into 0.25 into 0.08 into zero point 0.1. Okay. So up till here, any questions? Okay.
No, ma'am.
Yes. Okay. So let's see how this algorithm works. So this was we have seen just example. Now how we carry out this in actual procedure. So procedure involves three steps. First is initialization step, forward pass and backward pass. Now, initialization step, two data structures are used. First is the C matrix and D matrix. Now we have, what we have is, we have a corpus and we want to know the probability of a sentence. Then we have POS tags associated with it, and we have a transition matrix and emission matrix. Transition matrix, and we have a emission matrix. So these are the data structures that I already have. Emission matrix. So next is C and D. These two matrices are used specifically in this Viterbi algorithm. So what do these do is, so this first, basically these two help us search for, if I am at first word, what are the chances that I am going to second word. So basically what we have traversed over here, we have moved from O to this next VB to next O. So basically this stores, these two data structures stores the intermediate values. If I'm at O, I'm moving to second word. If I'm at second word, I'm moving to third word. Okay, so these two stores the intermediate values of the traversing from one word to another. Traversing the basically traversing the whole transition graph. Okay, so in initialization step, we initialize this first column over here, and in forward pass, we move from left to right. We populate, we generate these values from this one. third column from second column, and so on, kth column from k minus 1th column. Similar goes for this D matrix. So we generate second column from first column, third column from second column, up to kth column from k minus 1th column. All right. So in forward pass, we'll move column by column, left to right. It's very obvious because we can calculate the probability of word 1, right? We can calculate probability of 1 given our initial states. Probability of second word definitely depends upon what was my previous word, right? So that is why a forward pass involves moving from left to right, column by column, and backward pass involves moving from right to left, column by column. Okay, now let's see what matrix C and D represents. So C matrix represent intermediate probabilities. Intermediate probabilities of visited states. For example, if so this x-axis is tags that I was having, verb, noun, other, three tags or three states that I was having. And this y-axis represents number of words in the sentence. So sentence was I love to learn. So I love to learn. Okay. So this value represents what are the chances that I'm at verb and I will go to I. Okay. Similarly, so if my sentence was I love to learn, my sentence was I love to learn. And so what are the chances that this I was emitted from verb state, noun state, or other state? Okay, so if I'm so this will give me the probability. If this was 0.2, 0.1, 0.05, maybe something like that, whatever. Okay, so what are the chances that I was at tag I and my first word appeared which was I? Okay, so this will give me this probability. So I have to initialize this. Next, this love will depend upon what are the chances that I was at a particular state. So if I was on verb, what are the chances that love will appear next? And if I'm on the state other, so what are the chances that love will appear next? Okay, so this will these columns value will depend upon previous value. So this whole table stores the probability values. What are the chances that I'm at a particular tag and next word in the sequence is appearing that I'm learning. So this is specific to one sequence. So if I'm talking about this whole sequence, so what are the, so this will give me all the intermediate values. Okay. Similarly, this D matrix will give me, instead of probability, it will give me the state, the name of the state that is giving me maximum probability. Suppose I was here at W2. Okay, I was here at VB and I can move to noun and I can move to other. This will also give me term W2 and this will also give me term W2. So both of these states will give me W2. Okay, so this is giving me let's say maximum probability. So I will store O. So this I will store this second tag over here, that this is giving me higher probability, and I will store 0.5 plus 0.5, and this was giving me 0.5 and 0.1. So this is lower, so I will store 0.25 over here. Clear? Any confusion about this? I will store the maximum value for if I was at T1. T1 was, let's say, verb. So I was at T1 over here and I can move to W2 using two paths. Okay, so I will store the value state, which state, via which state I'm going with the to W2 with the maximum probability, and I will store the probability value in the table C and I will store the state value in table D. Okay. Let's see the example. So uh, this is initialization state. So I was here. Now see, so in the initialization step, I will calculate only first column. Okay, because first calculating first column depends upon only one word, and start state I was having. Okay, I was at pi initial state, and I want to calculate the word of w1. So w1 can appear either over here, either over here, or either over here. W1 can appear anywhere. I will calculate the probability that W1 was higher if I am at tag T1. Okay. So what are the chances that I will choose this one, or I will select any other word? Okay. So initially, if I'm at initial state, if I'm at pi state, if I'm at pi state, I will go to T1 or T3 or T2. So this value is basically representing, like I'm going from pi to T1, and this is representing in T1 that word W1 was present. This T2 will represent I was at pi, and I'm moving to T2, and that word was present, W1 was present. This value will give me the word W1 was present at that T2. Okay, this Tn will represent that I was at pi, and I am moved to T3. Basically, if this was 3, I have moved to T3, and what that word 1 was present over there. So all the possible probabilities, if I go to this one, or this one, so all the possible probabilities will be stored in this column. So calculating the initialization step is the easiest one. Okay, so and how do we calculate that? So this is pi I multiplied by this value. So this value is the emission probability, and this value is the transition probability. So transition probability from pi to T1, this one, and T1 to W1. So this is emission. Okay, so multiplication of transition and emission. Again, multiplication of transition and emission, transition and emission. So from pi, I have decided, like for all the possible states I was having, if word 1 appear in any of the states, what are the possible chances? Okay, so this probability matrix will give me all the possible scenarios that can appear for a sentence, at the maximum that can appear. Okay, uh, this is clear initialization step. Next is forward pass. So in the forward pass, basically, let's see. So to calculate this value, I require this value, right? How? So first of all, for moving to second C12 is basically, it's nothing, that I want to, I'm at location, let's say T1, and I want to go to location T2, uh, and the word was W2. W2 is appearing in W2 is appearing in term okay, yes. So for this, calculating the second step, suppose I was over here, I was at maybe term T1 or T2 or T3. If uh, sentence was 2 letter long, I love to learn. So I love. So I was at love. That is second state. So from this state, movement of basically, uh, this will represent I. This will represent love. So what are the chances that previous word was at T1, T2, or T3? Maybe it can be at any of the possible states. What are the chances that I have moved from T1 to next state, and given that next state can be T1, T2, or T3, any of these, right? And in that state, what are the chances that love word is appearing? Okay, so out of all these three, maximum value will be stored. Getting my point? Point is, if I'm at a particular state and I want to search for the word love, if I'm at, let's say, T3, so I want to search for a word W2. Okay, so W2 is here also, and here also. So I will calculate the probability. First of all, transition of this to this and this to this. So I will multiply these two and calculate the maximum one out of this, and then I will also multiply this one. This is the transition from T3 to T3, and this one maximum of this first path, path 1, path 2 and path 3. Okay, little bit confusing, but overall idea is I think it should be clear ki what is happening. So this is transition, and this is emission, and this is previous value. So if previous value I was at T3, so this value was something, and this previous value was this one. So I was at C11, so I was at C11 multiplied by transition and emission. So this value is same as we have initialized. So transition probability multiplied by emission probability, and we have some previous value. Okay. So this is how forward pass goes. So we keep on doing this up till kth word. So we have k words. We keep on filling it. So this is why we call it forward pass, because we are moving from left to right, filling column by column. Okay, then we have backward pass. So in backward pass, now because we have filled the column, now we want to calculate the probability out of this whole column, which one is best. Now sentence was I love to learn. Okay, so I have all the chances. Like if I'm on state verb, I'm on state noun, and if I'm on state other. So okay, so I have this probability, some probability, this one, and this one. So this is highest. Let's say in this column, this one is highest. If out of these three states, which one is higher? But I need to check, like so backward pass is basically it will calculate like out of all these possible states, which one is representing my sentence, because love can be in all the three possible terms. So out of all the possible scenarios that we have calculated, my sentence belongs to which one. So that is calculated using backward pass. So in backward pass, we first of all calculate the column wise which is having the maximum value. Okay, so this is how it goes. So first of all we check, okay, word 5 was there, and this is matrix D representing the intermediate state. So I was at suppose this was 0 0.5, 0 0.4, 0 0.3 and 0 0.2. So it will say, okay, this is having highest out of this whole column, this one was having highest, so I will select this one. So this value is taken from C matrix. Okay, so here we will go to D matrix. It will say, okay, go to T3. So I will go to T3 in the previous one, and I will find 1 over here. Then it says 1 is the you have to go to 1, so it will go over here. Okay, so column by column basically we have to check where our word is appearing, word 5 is appearing, as well as which one is having maximum probability out of this whole column. Okay, so this is backward pass. So this is how we retrieve, and we say, okay, this is the path that we follow while transitioning, while learning our sentence. And final probability is calculated from multiplying these values from the C matrix. Okay, so this is a little bit confusing, but try and execute one example. And if you say so, I'll also explain with example in another class if it is not very clear. So So that's it for today. Only one algorithm is there that we have discussed. And so module 2 is completed. Tomorrow we have a assignment, 5-minute
हम
presentations.
वेंसडे को है ना